So what we're going to talk about now is a Newton's law problem with a ramp, with a block on it, with an extra. So if you have to push on this block right here with a force of 200 newtons to keep it from sliding down the ramp, what's the coefficient of friction? So the thing we're trying to find is what mu equals. This block has a mass of 7 kilograms and is at an angle of 35 degrees. So now we're going to draw all the forces on this ramp, or on the block, sorry. And we know we've got gravity pulling down on the block. We've got friction going this way. And it's going this way because if we didn't push on the block, if this force wasn't here, the block would go down the ramp. So we have friction, and you know that friction equals the coefficient of friction times N. If you remember, mu is what we're trying to find. And any other forces. The normal force, and of course this 200 Newton force where you're pushing down on it. So we're going to start by looking in the y direction, and let's set up our axis so that this is the plus y direction. Again, we always start sum of forces, y direction equals MAY. We know it's not accelerating, staying still. This is equilibrium, so it's 0. And what forces? Well, in the positive direction, we've got the normal force. So we'll go ahead and write normal force plus, and then you'll see we've got this 200 newtons, negative, because it's going down, 200 newtons, minus, well, I'll do a plus, a negative, mg cosine theta equals 0. And the mg cosine theta right here is the y component, because it's the adjacent side of this force of gravity, so it's right here, mg, the x component. So by solving this around, we're going to get that N equals 200 newtons plus mg cosine theta. Now, that was our sum of forces in the y components. Let's work about the x components now. Okay, so we're going to start, like we always do, sum of forces in the x direction equals max. We know it's not accelerating because we're in equilibrium, and we know that in the plus x we've got mg sine theta because it's going with gravity. Gravity's helping it down the ramp. And that should be mu times n because it's force of friction. Mg sine theta minus mu n equals 0. And now we'll get, let's see, move this around. This is what we're trying to solve for. So we get mu n equals mg sine theta, or mu equals n, mg sine theta. So now all we have to do is combine these two equations, and we'll get our answer. So all I did here was combine my expression for mu and my expression for n. So if we plug in our numbers, we get mu equals 7 kilograms times 9.8 meters per second squared times sine 35 degrees all over. No, actually, hold on. This, not all over the whole thing. All over 200 plus 7 kilograms times 9.8 meters per second squared cosine 35 degrees, and we get mu equal 0.154. That's your answer. And again, mu doesn't have any units because it's the relationship between the normal force and friction.